Today we are talking about atomic theory for Chem 1, and I am Amber Farlow.
And I'm Leah Wright.
Okay, to start off with, we're going to talk about Aristotle. Aristotle was like the first scientist that ever released really information about chemistry, that is. He said that there's 4 elements, and there's water, earth, wind, and fire. And he said that these 4 elements can change from one to another, such as water can change eventually into wind, and wind can eventually change into water, and so on and so on. They all can change into one another.
And then we have Democritus, and he came up with the theory that atoms are indestructible, solid, and indivisible. And they're also homogeneous, which means it's consisted of all the same stuff throughout. And then the properties are due to the size, shape, and movement of the atoms. And also, big thing to remember here, atoms cannot change. They're always going to remain the same.
Now we move on to the law of conservation of mass. And it is, mass is not created nor destroyed. It only changes forms under ordinary conditions. And atoms don't disappear or show up out of nowhere. So, yeah.
And then we have definite composition, which is like compounds contain the same elements in exactly the same proportions by mass. And I mean, it's basically just saying that like H2O equals H2O equals H2O, and so on. And then CO2 equals CO2 equals CO2, and so on. And it's basically just saying that it's always going to contain like hydrogen and oxygen, or whatever else is in the compound. Like it's always going to be that.
Now we're going to move on to John Dalton. He was an atomic theorist, and he stated 5 points about atoms and atomic theory. Firstly, he said that matter is composed of small particles called atoms. Then he said that atoms cannot be divided, created, or destroyed. Also, he said that atoms of one kind of element are identical to other atoms of that same element. Therefore, atoms of different elements are unlike. Then he said that atoms somehow combine into small whole ratios to form chemical compounds. And lastly, he said that in chemical reactions, atoms are somehow rearranged and combined and separated.
Okay, and then we have J.J. Thomson, who did the experiment with the cathode ray tubes. And in his first experiment, he had the question, what does the beam do in a magnetic/electric field? And what happened was, no matter like what he tried, the beam deflected toward the positive and away from the negative plate. So he concluded that the beam is composed of negative particles. And then in his second experiment, he had this paddle wheel thing inside of the cathode ray tube, and the beam was pointed at it. And then the beam was able to push the paddle wheel down the tracks. So therefore he concluded that matter causes particles to move. And of course he had the plum pudding model. So I just want you to think of like a chocolate chip cookie, and the little red dots would be the electrons, and the blue plus signs are the hydrogens. And basically this model states that the negative electrons are embedded in a sea of a positive charge.
Robert Millikan, he completed an experiment called the oil drop experiment. And while he was completing this experiment, he applied voltage to the oil that was dropping down through the hole, and he found that the drops with a negative charge, they rose up to the top. And from that information, he concluded that the charge of electron is 1.60 e to the negative 19 coulombs. And then he found that the mass of the H atom is 1 over 1,840.
And then we have Rutherford, who discovered that alpha particles are relatively large and positively charged bits that resulted from some forms of nuclear decay. And now we know that they are just helium nuclei, and they have 2 protons and 2 neutrons. And then he also did the gold foil experiment, which is where he basically sent alpha particles through a piece of gold foil. And he found that a large number of the alpha particles got deflected. And that's because some of them were hitting the dense nucleus within the atoms of the gold, and then the others were going straight through because they weren't hitting the nuclei. And then his conclusion was that atom is mostly space with a small dense nucleus, and electrons are in orbit around the nucleus.
And now we move on to Goldstein, and he found protons, and that he found that the positively charged particles coming out of the experiment opposed to direction of the electrons, and that's why they're called protons. And
then we have Moseley, and he figures out that elements have different numbers of protons, so therefore the number of protons determines the identity of the element.
Then we have Chadwick. He found the neutrons, and he said that the mass of the atom is now accounted for because he found the neutrons.
Okay, and now we're going to talk about the parts of the atom. And for the proton, the symbol is P, the mass is 1, and the location is in the nucleus. For the neutron, the symbol is N, the mass is 1, and the location is also in the nucleus. And for the electron, the symbol is E negative, the mass is 1 over 2,000, and the location is in the electron cloud. And you also need to remember that for the proton, the charge is positive 1, for the neutron it's 0, and for the electron it's negative 1.
Now we're going to move on to the atomic scale. And about the atomic scale, most of the volume is empty space in the atom, and most of the mass of the atom is in the nucleus, which is the protons and the neutrons. And the electrons are just found outside of the nucleus in the electron cloud.
Okay, and then we have the atomic number, and it's represented as Z for some reason. And then the atomic number identifies the number of protons, and it also identifies the element. So if you know, carbon, if you look on the periodic table, has a 6. That is the atomic number, and it's also the number of protons. And then for phosphorus, it's the same thing. Its atomic number is 15, and that also represents the number of protons.
Okay, now we're going to talk about mass number. The symbol for mass number is just a capital A. And the mass number is the number of protons plus the number of neutrons. And mass number is not the same thing as an average atomic mass, and it is not on the periodic table. And when you write the mass number, for instance, you have C, which is carbon. You have to put a hyphen there, and then you put 12 because that's its mass number. Now for quarks. Quarks, protons and neutrons are not fundamental products of this. Protons are made up of 2 up quarks and 1 down quark. Neutrons are made up of 1 up quark and 2 down quarks. Quarks are also held together by the gluons as shown in the picture beside us.
And now we're going to talk about the nuclear symbols. And basically the U would be any element. That could be your C, F, P, if it's carbon or fluorine or whatever it is. And then the 235 up here, that's just the number, like that could be whatever mass number of that element is, and that's your protons plus your neutrons. And then the number below the element is the atomic number, which is your number of protons, and your 2 plus or 2 negative, 1 negative, whatever charge it is, that is just your protons minus your electrons.
Now for isotopes. Isotopes are atoms of the same element. They have the same number of protons, they just have different masses because of the different numbers of neutrons. And with carbon isotopes are C12, C13, and C14.
So for atomic mass, it's basically just the average of all the naturally occurring isotopes of that element. So like what Amber was saying about C12, C13, and C14, the reason they have different numbers is because C12 has 6 protons and 6 neutrons, and then carbon 13 has 6 protons and 7 neutrons, and then carbon 14 has 6 protons and 8 neutrons. So as you can see, they all have the same number of protons, they just have a different number of neutrons, which adds to the mass of the whole particle, making carbon 12, carbon 13, and carbon 14 all have different masses. But then the average of all those gives you carbon 12, which is your atomic number on the periodic table.
Now for the nucleus. Nucleus is found in the center of the atom, and it's 100,000 times smaller than its atom. And the nucleus contains most of the atom's mass because it contains the 2 subatomic particles, protons and neutrons. And then the 3 main subatomic particles are the protons, neutrons, and electrons.
And that's for the whole atom.
Yes.